This is Mrs. Saguchi, and I'm hoping this video will help those of you that are struggling with substitution. So I'm going to take you through the steps of substitution and then solve a couple of problems with you. I'd like you to make sure you're taking notes and writing this down with me on your own paper. So first of all, when I'm solving using a system of equations, I need to make sure that at least one of my equations has an isolated variable. So you can see in this system of equations, my first one has an isolated variable, and that is the y. So I'm going to circle that y with a yellow pen here. Since that variable is isolated, I know that y is equal to 6x minus 11. And I'm going to look at my second equation and see if there's anything in that equation with the variable y. And there is, right there. So in an effort to only have one variable, I'm now going to substitute that y in the second equation with the expression on the right side of the equal sign. So now I'm going to rewrite my whole second equation, negative 2x minus 3. But instead of multiplying it by y, since I already know what y is equal to in terms of x, I'm going to replace it with that expression, 6x minus 11. That eliminates y from that equation completely. Now I can solve the equation to find x because x is my only variable. So now I'm going to use the distributive property, multiply this 3 times the 6x, that's minus 18x, and then I'm going to multiply the 3 times the minus 11. Since they both have a negative symbol in front, it's going to become plus 33, and it equals negative 7. Now I'm going to combine my like terms. I can see right away that I have a negative 2x and a minus 18x. Those are like terms, so I can combine them, and that becomes negative 20x. Putting down the plus 33 and the equals negative 7. I don't have any more like terms, but since my x is on the left side of the equal sign, I'm now going to subtract 33 from both sides. It cancels out here, and I'm left with negative 20x equals negative 40. My last step in solving for x is to divide both sides by negative 20, and I get x equals positive 2. But I know that with a system of equations, my solution is an ordered pair or a point. So now I need to use that information, that value for x, and now I'm going to use substitution once again to find y. So if you go back to your original equation, the one that's y equals 6x minus 11, I can take this 2 and I can replace the x with a 2. That will allow me to solve for y. So now I'm going to put the 2 there, so it's 6 times 2 minus 11. 6 times 2 is 12, and 12 minus 11 equals 1. So now I've found the y value as well. So I have found the solution to my system of equations, written as a point, because remember you write points with the x-coordinate first, so I'm going to put the 2, comma, the y-coordinate is 1. I have to verify it just to make sure I did it correctly. So I go back to my 2 original equations, and I'm going to plug that point back in. So remember, the x is 2, the y is 1. My first equation was y equals 6x minus 11. So to check it, I'm going to put in a 1 for y and a 2 for x. I'm hoping the left side will equal the right side. 2 times 6 is 12, and 12 minus 11 is 1. So 1 does equal 1. Awesome. Now I need to verify it with the second equation, which I'm looking back up here. Negative 2x minus 3y equals negative 7. So once again, I'm going to replace the 2, or excuse me, I'm going to replace the x with the 2 from the point that I got. I'm going to replace the y with 1. And now I'm going to check to make sure the left side of the equation equals the right side. 2 times negative 2 is negative 4. Negative 3 times 1 is negative 3 or minus 3. Negative 4 minus 3 is negative 7. So negative 7 does equal negative 7. Once you've verified it with both equations, then you're good to go. So if you feel like you would benefit from watching one more example, go ahead and click on the next video.